Hey Gators, welcome back. Today we will represent linear relationships using verbal descriptions, tables, graphs, and equations. So let's get started. It says Mark runs at a constant rate as shown in the table. Graph this relationship and be sure to label what each axis represents. So it says the x, which is in the left side column, is time spent running in minutes. So under the x-axis, we're going to put minutes, and on the y-axis, we're going to put kilometers, or km. We need to plot these points. So our first coordinate pair would be 2, 0.5, or 1/2, 4 and 1, 6 and 1.5, and 8 and 2. So let's go ahead and start by plotting these. So we have 2 for the x, so I go here to 2, and I need to go up to 1/2. I'm going to put a point there. Then we have 4, which is here, and I need to go to 1. So 4 up to 1. We then have 6, and we need to go up to 1.5, which is in the middle of 1 and 2. And then we have 8, and we need to go up to 2. So here is our line. We need to write an equation to show the relationship between x and y. So how do we go from x to y? Well, we can see that the rate of change from 1.5 to 1 is plus 0.5. From 1 to 1.5 is plus 0.5, or plus 1/2 if you wanted to say it that way. And then from 1.5 to 2 is plus 0.5 as well. So we know our x will be 0.5x. And what are we adding each time? So it would be 2 times 0.5, which is 1/2. And so our y equals 0.5x. And then it says, in a sentence, explain what the point 8, 2 represents in the situation. Well, we know 8 belongs with minutes, because 8 is x on the x-axis, and minutes represents x-axis. And then we know that the 2 is 4 kilometers. So basically what this is saying is if he spends 8 minutes running, he will run a total of 2 kilometers. All right, so let's continue on. A bucket of water has a leak in it. The relationship between the time in hours and depth of water in inches is shown in the table. Graph the relationship and be sure to label what each axis represents. So again, on the left-hand side, we have the x. For the x-axis, this would be hours. And then on the y-axis, we would put inches. So let's look at our first point. We have 0, 8. So 0 is x, 8 is y. We have 1, 6, 2, 4, 3, 2, and we have 4, 0. So let's first go ahead and plot these. So 0 is here. We go up to 8. We have 1, 6, 2, and 4, 3, and 2, 4, and 0. So what is our constant rate of change? Well, from 8 to 6, you're subtracting 2. From 6 to 4, subtracting 2. 4 to 2, you're subtracting 2. So our rate of change is -2, which goes with our x, so -2x. But what would so if we looked at this, y equals mx plus b, what would our b equal? Well, b is your x-intercept. What is an x-intercept again, Miss Cipher? Well, an x-intercept is when the coordinates are passing through the the y-intercept. The y-intercept is when the point is passing the y-axis. We know the y-axis is here. Is there any points we see on the y-axis? Yeah, we see 0, 8. So our y-intercept would be 8. So our equation is y equals negative 2x plus 8. And then it says, in a sentence, explain what the point 4, 0 is. So what is this point here? So if it says in hours and depth of water, in 4 hours, the depth of water is at 0 inches. All right, Gators, that is all for today. I will see you in the next one. If you have any further questions, please reach out to your math teacher through Canvas inbox. Other than that, have an awesome day.